We're going to create our first program today that uses numeric data. Before we do that, we're going to set up option strict. So we're going to go into the Tools and Options, and you're probably going to see the Environment tab open like that. But you're going to go into Project and Solutions to VB Defaults and switch option strict to on. Right now by default it's off. You want to turn it on. Make sure you hit that little black triangle over by Projects and Solutions. Go to VB Defaults and turn Option Strict on. That will make Visual Basic be stricter when it comes to the we use our variables and data in programs. It'll help us be better programmers in the future. Our new project we're going to start today is called Calculations. We'll check out some of the math operators we can use in Visual Basic. Change the name of the form, well, not the name of the form, the text of the form so that it says calculations at the top. That's a good title for this program. And of course this form is going to need to be a lot larger than what Visual Basic originally gives to us. We're going to need 4 buttons to get things rolling. So we'll grab 4 buttons out of the toolbox. I'll go ahead and line these up. I'm putting mine over on the left-hand side, arranged vertically. I want them to look pretty similar, so I'm going to select all of them using Control and mouse click. I'll resize all of them at the same time. And then we're going to adjust some colors. First, we'll adjust the forecolor. Today we'll make it some kind of a brown. Next we'll adjust the back color. Since that was sort of dark, we'll make this one kind of light with wheat. And the font certainly needs to be enlarged. We'll go ahead and leave the font type the way it was, but we'll adjust the size to make it a little easier to read. And our 4 buttons have been created. Let's adjust the names of these buttons. There's going to be a bunch of math action here, so I'm going to call this lowercase btn and then a capital M for math 1. btn math 1. Not that bad of a name. You might have a pretty good idea what we're going to call the next button. We'll head over there, select it, and change its name to btn math 2. The third button will be called btn math 3. Our 4th button will be called btn math 4. Now we'll adjust the text property and put in what looks like some mathematical operations. Some math that we want to have simplified. So in this one I'll do 5 plus 20 divided by 10. I'll use the fraction bar to indicate division. And our second button, we'll use maybe some subtraction and multiplication this time. We'll go with 18 minus 2 times 4. The asterisk means multiplication. Now the truth is you could put an X in there if you wanted to. You could even use just parentheses around the 4. No math work is being performed in the text property. We're just displaying something for the users. The real action matters in the code. Here on this next one we're going to use the caret. It's above the 6 on the keyboard. That's really going to be 4 to the 3rd power. You see a button like that on many scientific calculators. And that's available to us in Visual Basic as an operation. Not all programming languages let you do that. This last one, we're going to have a little demonstration of the distributive property. I'll have 7, and then in parentheses, we'll put 9 plus 1, and end our parentheses. As you probably have surmised, what we're planning to do is allow users to click on these buttons, and then answers to these simplified math problems will appear in a label. We're going to need to get a label so we can show the answers. Here we go. I'll change the name of this label to LBL Answer. That's where the answer is going to go for any of these problems. Certainly it's awfully small. I want to have it much larger, so I'll make auto size false, and then we can size it to whatever we would like. That's a lot larger. Notice by default the text is in the upper left corner, or top left. We're going to change that to middle center. Make the font considerably larger. And we'll change the foreground color to something else. We'll make it some kind of a green. And that's where our answers are going to go. I'll get another label to go on top of this one just to serve as a prompt, or almost a label for the label. The text is going to say answer, but I'm not even going to give this label another name. It's just going to appear above LBL Answer to let users know what's underneath it is an answer. A lot like on a scoreboard where you see home and visitors, and it just stays on the scoreboard the whole time so that you know the number underneath it is the score of either the home team or the visiting team. I'm adjusting the color and the font of this as well. And now it's ready. Now we probably don't want label 1 to show up when the program originally runs. It's useful right now to help us center things and see the color of it. But when we run the program and at the very beginning, we don't want anything to appear there. So we'll take that text out so that it is blank when the program actually runs at the start. All right, let's do some coding. Of course, we'll put in our name, date, and the program and description at the top. And it's time to do some math work. We're going to declare a variable, and this variable actually will not work well at first. We're going to have to change it later on. But numeric variables, a couple of the ones we'll deal with are integers, doubles, and decimals. I'll call this int answer as integer. Now that would mean that everything that happens along the way is an integer, not a decimal nor a fraction. And as you'll see in a minute or two, that's going to be an issue for us. I'm going to actually have to change the data type of this variable, and I'll also change its name. Realize though that if I declare, or we declare a variable as an integer, we're expecting numeric data to be just integers. Again, no decimals. The purpose of this is to hold the answer that we're going to calculate. So let's do some math. I'm going to have int answer equal what I put inside that box, in the button, which was 5 plus 20 divided by 10. But we're going to run into a problem because 20 divided by 10 could give us a decimal answer. Visual Basic returns a double on that. And you may not know what that means yet, but that means we can't use an integer here. So we'll change the data type to a double, and since that's going to happen, because doubles can be decimals. So I'll put a lowercase dbl in front of answer to indicate that this variable is holding a double, and we'll declare it as a double as well. Make another change down here, and now we're okay. We again take the right-hand side and assign it to the left. So Visual Basic will follow the order of operations and do 20 divided by 10, That's 2. 5 plus 2 is 7, and that will go in DBL answer, a variable with some area set aside in memory. Now we want to display this in the LBL answer. We've displayed text before, strings inside the text property, so we'd think we could display this number too. But text properties of a label and of anything expect strings, not numbers. We're going to have to convert our number into a string. That may seem odd to you at first, but if you think about it, your zip code, although it's all numbers, really we don't do math with zip code. We could make zip codes out of letters if we wanted to. We just happen to use numbers. Same for your phone number. We use digits for those, but we could use letters. So we're going to convert this, and Visual Basic gives us a possible solution here, and it's not the one I recommend using. This looks like a little too much work. We're going to use the convert string, which is CSTR. And then in parentheses, we'll put DBL answer. CSTR is a conversion to string function. You've learned about functions in algebra class. You input something and you get something out. A toaster can give you a function. You put in bread, out comes toast. You put in a frozen waffle, out comes a warm waffle. We're going to use this to convert number to a string. We input a number and out comes a string. That's good because that's what has to go into lblanswer.text. If we assign something to lblanswer.text, it's got to be a string. We'll simply convert our number to a string using the CSTR function. This will work, and if we run the program, we will see the correct answer displayed in the label. Click on the button, there's the answer, 7. All the math work was done, stored in a variable. That variable was a numeric variable. We had to convert the value of it into a string, and then we were able to display it. You might want to try right now pausing this video to see if you can code the next 3 buttons. In a moment, we're going to do the next button. I'm going to declare DBL answer as another variable again, and that's legal to do. You may or may not have noticed that these subs have the word private in front of them. They don't know what the other subs are doing. So I can use this same variable name again, and it doesn't matter. The other subs don't know that it's being used. They're 2 totally different variables, 2 different spaces in memory. So I'm going to put 18 minus 2 times 4. Now here I absolutely have to use the asterisk. That's what Visual Basic uses for multiplication. Once again, in the text property, I could have used the letter X if I wanted to do that instead. And I'll display the result in LBL answer. And that means we'll have to use the convert to string function, CSTR. We'll do the same thing in this third button. I'm repeating myself quite a bit, so I'm going to copy and paste and simply change what goes on in the math operation. 4 to the 3rd power plus 11. In the order of operations, of course, that exponent will come first, so that should give us 64 plus 11 is 75. The last one is a little tricky. I'll again copy and paste, and then I'm going to type exactly what was in my text, which was 7 parentheses 9 plus 1. You and I know that we need to use a distributive property here, but Visual Basic doesn't. It wants to know what's supposed to happen between that 7 and the left parentheses. We have to explicitly put in a multiplication operator, and now Visual Basic is happy it knows what it's supposed to do. We'll run the program and get our results. And Visual Basic does all the math work for us.